Welcome back to the Dr. Liu VCE Physics channel. In this video, we'll be going through the 2018 physics exam, focusing on questions related to the generation and transmission of electricity. My explanations may not be perfect, so if any teachers, parents, or students notice any errors, please feel free to offer your feedback. A group of physics students conducts a controlled experiment to investigate the phenomenon of electromagnetic induction. The students place a coil within a uniform magnetic field, as shown in the diagram below. The independent variable is the factor that you change or manipulate in an experiment. Here, you are spinning the coil at 3 different speeds, so the speed of rotation is the independent variable. The dependent variable is the factor that you measure to see how it responds to the change in the independent variable. In this case, you are measuring the peak EMF, which is the dependent variable. The controlled variables are the factors that you keep constant to ensure a fair test. Here, the strength of the magnetic field is kept constant, so it's the controlled variable. Figure 4 shows a simple AC alternator, with the output connected to an oscilloscope and a light globe. The oscilloscope can be considered as having a very large resistance. The coil is rotated, as shown in Figure 4. The output on the oscilloscope is shown in Figure 5. To ensure a DC battery provides the same average power as an AC alternator, its voltage must be equal to the root mean square, RMS, voltage of the AC source. This is because the RMS value is defined as the DC voltage that would dissipate the same amount of power. Therefore, you can calculate the required battery voltage by first determining the peak AC voltage from a graph and then substituting it into the formula for RMS voltage. The period of rotation is inversely proportional to the rate of rotation, while the peak electromotive force, EMF, is directly proportional to the rate of rotation. Therefore, doubling the rate of rotation will halve the period and double the peak EMF. A physics class is investigating power loss in transmission lines. The students construct a model of a transmission system. They first set up the model as shown in Figure 7. The model consists of a variable voltage AC power supply, 2 transmission lines, each of 4.0 ohms, total resistance equals 8.0 ohms, a variable ratio transformer, a light globe, and meters as needed. The purpose of the model is to operate the 4.0 V light globe. A variable ratio transformer is one in which the ratio of turns in primary windings to turns in secondary windings can be varied. The resistance of the connecting wires can be ignored. Given a transformer ratio of 4:1, the current in the light globe is 4 times the 3A current in the transmission lines. The power dissipated in the light globe is calculated by multiplying the current flowing through it by the voltage across it. The total power output from the power supply is the sum of the power dissipated by the globe and the power lost in the transmission lines. The power loss in the lines is calculated using the formula. To find the total output power, you add the power dissipated by the globe, which was calculated in a previous step, to the calculated power loss in the lines. Finally, the voltage output of the power supply is determined by dividing the total output power by the current flowing through the transmission lines. The total voltage output from the power supply is the sum of the voltage drop across the transmission lines and the input voltage of the transformer. This is because, from the perspective of the power supply, the transmission line and the transformer's primary coil act as a series circuit. Voltage across the transmission line. This is calculated using Ohm's law. Input voltage of the transformer. In an ideal transformer with a 4:1 ratio, the input primary voltage is 4 times the output secondary voltage. Therefore, you can calculate the input voltage by multiplying the globe's voltage by 4. Finally, add these two calculated voltage values together to get the total voltage output of the power supply. The power loss in the transmission lines is the product of the square of the current flowing through them and the total resistance of the lines. In this case, the total resistance of the lines is 8 ohms. To operate the light globe correctly, the transformer's output remains 4V and 12A. With the new transformer ratio of 8:1, the current in the transmission lines is reduced. You can find this current by dividing the secondary current, 12A, by 8, which gives you 1.5A. The power loss in the lines is then calculated by squaring this new current and multiplying it by the total resistance. The total power transmitted through the lines remains constant regardless of the voltage. Since power is the product of voltage and current, the current in the lines is inversely proportional to the voltage. A higher voltage leads to a lower current. According to the power loss formula, the power lost in the lines is proportional to the square of the current. Therefore, transmitting power at high voltages significantly reduces power loss. This section covers the generation and transmission of electricity. It is worth 17 marks, accounting for 13.1% of the total 130 marks. Multiple choice questions. 1 mark. Question 20. Variables: independent, speed of rotation dependent, peak EMF controlled, magnetic field strength. Short answer questions. 16 marks. Question 4. AC generator. The period is inversely proportional to the rotation speed. At the same time, the peak EMF is directly proportional. The root mean square, RMS, voltage is the effective DC equivalent. Question 5. Transformers and power loss. The total power output equals the power dissipated by the load plus the power lost in the lines. Power loss is proportional to the square of the current. Step-up transformers increase voltage and decrease current, which significantly reduces power loss during transmission. Should you require assistance, please feel free to connect via WeChat or WhatsApp and send an email. Thank you for your attention. Kindly note the details of Dr. Liu's VCE Physics, Chemistry, and Biology channels.